write a program using the ladder diagram. So this is a program that will help us, or that will help the PLC to run based on your set points. So the way you want to PLC to operate, then we are going to program it using the ladder diagram. And we say that in ladder diagram, we represent it in writing programs. In writing a program in PLC is equivalent to drawing, switching circuits. So writing a program is equivalent to drawing a switching circuit. Equivalence to that, and the switching circuit is drawn in ladder diagram. So there is also something that need to be noted, that this format of the ladder diagram requires that the circuits are arranged in series of horizontal lines, which are containing the inputs and the outputs. So the format requires the circuits to be arranged containing the inputs and outputs. So in most cases, so we have got the inputs, which in most cases these are the contacts, and the outputs here is usually could be the coils. So when we talk about the contacts, then we've got two contacts. So it can either be normally open or normally closed. So NC, or this one is NO. So the coil is that, the output could be the coil. So again, the input proceeds to the input proceed to the output, and also inputs are either normally opened or normally closed. So the input proceeds all the way to the output, and input can either be normally opened or normally closed, while the output could be a coil. So the output is usually represented with either, so the output is represented with these signs, with the signs. It can either be like that or just like that. So in our ladder diagram, when you see these signs, it means the output, or when you see that sign, it means is the output. So when you are given a program and then you are told to design the ladder diagram, so when you show this, then it means it is the output, and the other one, or the other one, any you can use, you just pick any. So but the two represent that it is the output. Then again, something else that we need to note is that the program has the following components. The program has three components. So one, it has got what we call an address. Two, it has got what is known as the instructions. And lastly, three is what is known as the data format. So any program in PLC, it has to have three components. It has to have an address, it has to have an instructions, it has to have a data format. So let's see an example. Let's see an example. We can be given a ladder diagram like this, and then we have this. Then this label A and this one label C1. Then we can also have this, can also be given this client, and then you are given. So let's set the points to be, let's say 24 volts, and this one is 0 volts. So can say this is P and this is relay 2. So when you look at when you see this, that one is the normally opened. So we start from A. We say that one is a normally open switch. It's a normally open switch which forms the output. Sorry, which forms the input. Then Z1s form the output. And then you go to line number 2, P. This one represents normally closed, and this one is a normally closed switch, which is still in case, which is still forms the input. C2 forms the output. Forms the output. So this is an example of a ladder diagram. This is an example of a ladder diagram. An example of a ladder diagram. So we say the inputs is usually the inputs are contacts and the outputs are the coils. So the output, this is a coil 2, this is a coil 2, and this one is coil 1. So as earlier on we say, writing a program is the same as, or is equivalent to the drawing switching circuits, and these switching circuits are represented or are drawn in ladder formats. They are drawn in ladder formats, which has got the inputs and the output. And for our case, we are saying the inputs we use the contacts, and the output we use the coils. And this what they represent. We say this the output. We can use this to represent the output. The contacts are these ones. This one represent the normally open. This one represent the normally closed contact. And we also say in PLC the program has got 3 components. It has to have an address. It has to have the instructions and the data formats. So let's see the ladder diagram or ladder instructions. Let's see ladder instructions. So the second thing is the typical ladder instructions. Typical ladder instructions. So we can have here the instructions and then the descriptions. So one of the instructions would be the load. So load means it's a logic state of start input. So this one means load the logic state of the start input. So that is what it means. The descriptions of the load, you need load logic state of the start input. Number 2, you can also be given this load note. Let's write this in capital letters, load note. And load note, this one say logic state of start input and invert. So this one load logic state of the start input and invert. Number 3, you can be given an instruction and this one is described as logic and operations. This is logic and operations. We are going to see example how we are to play around with these instructions. So number 4 is another instruction, goal OR, and this one is the logic OR instructions. Logic OR operations. Number 5 is OR NOT. OR NOT is a logic OR NOT operations. Logic OR NOT operation. You can also be given this number 6, the out, and this one forms the output. So these are just but a few of the typical ladder instructions. These are of the instructions. So we want to see how we are to play around with this. But first we are supposed to know what all means. Like we say, when we say load, then it means you load the logic state of the start input. Load not, it means logic state, load the logic state of the start input, and then you do inversion, you invert. And is a logic and an operation, or is a logic or operation. This one is means logic or not operation, and the other, the last one out is described as the output. So it is described as the input. So let's see the programming. So one programming. So we had said in programming a BLC, then it has got 3 components. It had the address, that's the instructions, and the data format. So let's see them. We say there is the address, there is the instructions, and then there is also data format. So in address we can have, let's say, the initial, or which could be you are supposed to load, and the data could be you are loading A, and then address 1 could be out, and the data format is the C1. 2 could be load not, and the data format is D. 3 is out, and this one you out. C2, 4, and this one you end the program. you end the program. So you end. So this is a programming. In programming, it must have an address, it must have an instructions, and it must have a data format. So for example, if we are told to draw another diagram of this, then what we are going to do, as usual, then you are supposed to draw two parallel, two lines, and then you can set the points, the voltage if you are not given, to be 24 volts, and then this one should be, you can call this one 0 volts. Then you start from number 1, that is number O, which is load A. So load A means, so load A, you draw that, then represent A, and then address 1 is to output C1. So the output is C1. You come to address 2. Address 2, the instruction here is to load not. That means you are going to apply this, and that one is what the data format is P, and then 4, that is address 3, is telling us to output C2, is to output C2, and then address 4 is telling us that we end the program. So that is an example of a ladder diagram. So how do we get this? Is first of all we are supposed to be given the programming. That means we are supposed to be given an address, we are supposed to be given the instructions, and lastly the data format. Then from there we can come up with a ladder diagram. Still, you can be given a ladder diagram and then you are supposed to write a program. That means you're going to write to come up with the address, the instructions, and the data format. So whichever the way, there should be no problem. So let's see another example. Program. We have been given the program or the programming. Here we've been given the address, we've been given the instructions, and the data. So the address is the initial one we are supposed to load, and then the data is A, then 1 then we say end, that is also our instructions, P, and then 2 is out, C, and 3, then it's a ends. So let's come up with the ladder diagram. Draw the ladder diagram. Draw the ladder diagram of the PLC. So what you're going to do, we're going to draw two lines. We're going to draw two lines. We can put here to be 24 volts, 0 volts, and then we start from the first address, which is O, and from O, when you go to O, then the instruction here, the instructions, or what we have to do is to load, and we ask ourselves, what are we loading? Then we are supposed to load data A. So we are supposed to load A, the first one, we load A, and then you go to number 1, then you also told end B. So this is A, then again we are told end N, P, and then C. We are told output C. So again, we are supposed to output C. Then number 3, we are told we end the program. So that is another example. So we've been given the program, we've been given the instructions, the address, and the data formats. So in this, we are told we are loading A, we load A and B, and then we are put C. And then from after you have done that, then you end the program. Let's see if we can get another example. Let's see if we can get another example before we finish. Another one is, let's consider parallel switches. So let's here consider the parallel switch. So if we are given a program like this, we're given an address, we've been given instructions, and then we are given the data. So the address could be 0, you load, data is A, and then the address, you go to address, or not, P2, the instruction there is out, which is ZR1, 3 is end the program. And then the question is draw the ladder diagram. Draw the ladder diagram. So let's see how we can draw this one. Let's see, as usual, you draw 2 lines. You can set the voltage to be 24, 0 volts. And then the first address is load A. So let's load A. We are loading A. And then number 2, we are told or not. Or not means you're going to connect this with another one. This one is or not, that means we cross that, and then we are told we do what? We output CR1, that is the relay, control relay, and then address number 3 is asking us to end the program, and then ya mwisho we are to end the program. So that is also another example. That is another example. So let's see another example. And here we are going to be given, it's going to give us the ladder diagram, and then we come up with the program, or the program itself. So we've been given something like this, and then we are given this A1, and then this one A2, C1, this is A3, this is A4, this is A4, A5. So here we are to come up with the program. So here we've been given the ladder diagram, and we are supposed to come up with the program. So in a program, there is the address, there is the instructions, and there is the data format. So instructions number 1, we start from here. So instruction number 0 is here load. We load number 1, A1. Address 1 is 2. The instruction here is N, and this one N, and not A2, and then number 2 is output out Z1. Then this instruction is for only this one. So we are loading this and not A2, and then we output C1. Then instructions number 3 is the load not A3, load not A3 number 4. These two components here are in parallel, so we are going to load A, and this one they are in parallel, so we are going to use OR. So we are going to load A. We say load you load A4, and then number 5 we say or A5, and then number 6 we have to do the output C2, and number 7 we end. And that is how to come up with the program. It is how to come up with the program when you are given the ladder diagram. So these were few things that I wanted to discuss with you, and maybe during your free time you can do maybe more examples, and if you find that you still have got some problem, then you can write down a comment to notify me that you still have problems, so that we can see how we can help each other. So after that you can say goodbye.